Hello student, myself Dr. Anita Chaudhary. In this session we will discuss about the components of computers. There are different components like input output devices, central processing unit, memory unit, control unit, arithmetic and logic unit, and we will discuss all these components one by one. So first we discuss about the computer. What is computer basically? What computer does? So a computer is basically an electronics device that processes the data based on some instructions. The instructions are stored in memory and capable to perform variety of tasks with high speed and accuracy. So that's why the computer is basically used, and it is consist with hardware components and softwares. So in the hardware category we mainly discuss about the central processing unit, memory, storage devices, input devices and output devices. Next, the computer operates on software programs that control their functions and enable the users to perform tasks from a very simple to the complex instructions and perform the data analysis like high performance computing. So you can see that there are different components basically, like monitor, CPU. In a CPU there are power supply, functions, fan, and different components are built on a motherboard. So motherboard contains the processor, cores, and memory, different types of memory like registers, cache memory, RAM, and these are the RAM slots, and various different ports like USB ports and other ports. And this is the mouse that is used as an input device. This is keyboard, and this is the flash drive used for storage, secondary storage, and the speakers. These are the different components. You can see them, okay, directly. And the components are basically motherboard, input units, output units, central processing unit, graphical processing unit, random access memory, and storage units. So next, this is the basic block diagram of the computer. So computer is having three basic components. Okay, first one is the input unit, output unit, and the central processing unit. The main component is the central processing unit. In the central processing unit there are three subcomponent. One is the arithmetic and logic unit, and next control unit and memory unit. So all the operations, either arithmetic and logical operations, are performed by ALU, and it works on logic gates. And next one is the control unit. Control unit controls all the buses and the instructions that are delivered to the ALU and delivered to the memory. So an entire circuit is controlled by the control unit. Next, the memory unit. All the data and instructions which will be executed by and fetched by the ALU are stored into the memory unit, and in this memory unit the read-only memory is accessed. Next, the input units of the computer system. So the input unit is used for receiving the instructions basically, and from the user, and the calculations are performed on these instructions, and this includes all the input devices which are responsible for reading the data that is entered by the user. So the input data can be either the image, letter, or numbers that are entered by the command or using the input devices. Next, functions of input unit of a computer system. So basically the what type of functions are provided by the input unit. So it first takes the command from the user and to perform some computations, and it basically convert data in a digital language format. Digital language format is basically 01 formatting that is supported by the computer, and computers work on the 01 language only. Next, it sends the data to the processing unit to perform the to perform or to analyze the data or to execute the instructions. And there are different types of input units like keyboard, scanner, trackball, MICR, touchpad, touch panel, joystick, barcode, and mouse, OCR. All these are the input units that give the data to the computer, and computer process the data. Next is the output unit. So when a user executes some instruction, then it sends a set of instructions to the computer that are uh, that printed or displayed on the output devices, like the output is displayed on the monitor, and if you use the ATM machines and other motherboards, then you can fetch the printed slip also. So the output means you see something, you listen something, you can feel something. So that is the output, and the devices that work for the output are called the output units. The processor sends the transcripted instructions to the output devices for their executions, and like the monitor is one of the main component in the computer system to display the results to the end users. So our output unit basically work for displaying the results that are fetched either from the ALU and from the memory unit. So the basic functionality of the output unit are: it receives the instructions in machine language to execute the task, and it coordinates with the processor to get the instructions on time, and convert the machine language into the user friendly language so end user can easily understand what is the output, and it is the medium of between the user and the system for the to fetch the results. So, and there are different types of output units you can see in a computer, like monitor. You can see the out results on the screen. The printer, you can fetch the hard copy. Next is the plotter, projector, LCD projection panel, computer output, micro files, microfilms, and the speakers, headphones, earplugs. All these types of devices are called the output units. Okay, so these are the used for the sound systems. These are used for to see the images, and these are basically the monitor is basically a part of the computer system that you can feel it directly, and it is connected with the system. Next is the central processing unit. The central processing unit having the three subcomponents, which are the control unit, arithmetic and logic unit, and the main memory. So the all these components we will discuss one by one, and the processor is basically, we use the different terms on which the processor is work. So The basically processor can have different number of cores. Cores means the processing element basically, which perform the arithmetic and logic operations. This is a single unit core. So there are different processors are available in the market. Like if a processor is having only one core, then it is called the single core processor, as dual core, octa core, hexa, octa, quad core, hexa core, octa core and deca core. So on the basis of the number of cores in a system, uh, you call them accordingly, like single core system, dual core system, quad core system. So basically the central processing unit is represented using the processing units. So because everything is done by the processing unit, all the operations and the executions are done by the processing element. So that's why this is the important part in the entire computer. So that's why we talk about the processing elements and the number of cores. So now the processing element is work on the logic gates, and logic gates is work on a 0 1 format. So the computer or the central processing unit understand only 0 and 1. Okay, either 0 and 1, because it work on the logic gates. So logic gates is either on, off, 0 1. Okay, so and whereas the human is understand the English language, so there is converter is used to convert the human language into the machine language. So that's why the computer is having the compilers that translate the English language into the machine language, so computer can work on the given instructions. Next, it has the motherboard that with have this with the central chip, and it is a that is called the primary part of the processor, because it this central chip is basically hold the core processing element, and the this processor needs the input for execution of the instruction. So data and instructions are delivered to that processor, and processor coordinates with both input and output, because sometimes user enters the instructions and the data as well as, so the processor communicate with the input devices and displays the resultant to the output devices. So this is basically a diagram, flow diagram of the CPU. That this is the ALU, arithmetic and logic unit. So arithmetic and logical unit directly access these registers. These are called the register, and this is a kind of memory. Okay, so there are different registers, like A type, A, B, C, D, E, H, L, and stack pointer. Uh, Accumulator, A stands for accumulator. So accumulator is basically hold the last output, and these the data is stored in these registers, and the instructions are stored in this instruction register. So this and the instruction is basically in a narrative English format. So the decoder is used to decode that instructions, and this is the control unit that control the all the devices, and it is controlled by the this clock pulse. So, and this is the data bus to transfer the data in between ALU and the memory unit. So, and this one is the memory from where the data and the instructions are stored, and this particular address bus are used to define where the to specify where the instructions or the data is stored at. So the location is accessed using the address buses, and this address buses access the address from the MAR, memory address register. So the instruction address is stored, fetched using the memory address register, and this MAR basically access this address using the program counter. So basically program counter uh, stores the instruction which will be executing next, and this address will be sent to the memory address register, and memory address register sends this address to the memory unit, and from that location the data or the instructions are sent to the data buses and stored by the memory bus register, memory buffer registers, and instruction registers. So these like this the basic ALU's work, and ALU access the data. So you can see this particular chip is located on the motherboard. This one is the Intel CPU chip that is fused on the motherboard. So the function of the computer processor is basically CPU fetch and executes the commands that are given to the processor. It temporarily stores the data that being used by the ALU, and it controls all the communication between the memory and IO devices, and it performs all the arithmetic operations and logical operations that are stored or that should be executed by the computer. Next, the ALU or the CPU access the data from the memory unit. So memory is one of the most important part of the computer, and there are different types of memory available in the computer on the basis of their costing and on the basis of their speed. So this component of the CPU deal with the storage of the data, and it data is reached from available from the processor, either from the input devices or from the memory unit. So whenever the computer or CPU performs some instructions, then it access the data either from the input devices or from the memory unit. So it has some pre-existing programs that helps for transferring the data between the different part of the computers that are called already built-in programs basically, and the processor cannot process the data unless the memory unit saves it. So the data and the instruction that will be executed by the computer should be available in the memory unit, and the memory unit is basically work on two data is represented in two different categories. One is the bit and next one is the byte. Bit means a simple 0 or 1, only one bit, okay, and byte is a combination of bits. 1 byte contains 8 bit, okay, and bit is basically a single unit, and whereas byte is a combination of 8 bits, and both are used for measuring of the data size, like 8 bit or 16 bit or 32 bit. So that's how the computer is basically represent the data or the data buses and the address buses. So basically the memory is divided into the further two categories. One is the primary memory and second one is the secondary storage unit. The primary unit is basically the internal or temporary storage that is supported by the computer, and whenever the lights goes off in a computer, it is the data is completely erased from this primary memory. So that's why the primary memory is also called as a volatile memory, whereas the secondary storage is treated as a permanent storage, and after switch off the lights or disconnection of the electricity, the computer is still stored or kept the data in a secondary storage that is called non-volatile or the permanent memory. So the data which is important and which will you want to access in a future, that should be stored into the secondary storage. So this is the hierarchy of the computer memory. So the highest speed of the memory is called the cache memory, and the cache memory is further divided into the different level 1 cache, level 2 cache, and level 3 cache. The level 1 cache is having highest speed among all these three levels, and the storage capacity of the level 1 cache is low, but the speed is very high. Its level 1 cache speed is approximately equals to the speed of the core. Next, L2 cache. L2 cache having the higher storage capacity than the level 1 cache, but its speed is slightly lower than the L1 cache. Same L3 cache. L3 cache storage is higher than the L2 cache, but the speed is lesser than the L2 cache. So after that cache memory, the next storage is the primary memory. This is the volatile memory. Both the cache memory as well as the primary memory are both volatile memories. In a primary memory, this RAM. Okay, RAM is called the random access memory, and it further divided into two categories, static RAM, and this one is the dynamic RAM. Next one is the read-only memory. You can't change the content of the read-only memory, and the content are permanently stored on these memories. So this one is the non-volatile memory. So if there is a question that which memory is non-volatile, then the secondary storage and the random access memory, sorry, read-only memory are non-volatile memories, whereas the cache memory and random access memory are the volatile memories. So in an internal storage, only random access memory is a volatile memory. Next, the read-only memory. This is called the permanent storage, and all the necessary instructions and the programs that are needed for to work for the computer processing are all stored in a read-only memory. So this is the programmable read-only memory. This is the EPROM, and this is the EEPROM. All these memory we will discuss in a coming sessions. And last one is the secondary storage. This storage is called as a permanent storage and external storage also. The capacity of this storage is very high, but the speed of this storage is very slow. That's why it is not directly connect with the ALU or the CPU, but the storage capacity is very high, so all the necessary data is stored into the secondary storage. So the secondary storage contains these HDD, hard disk drive, CD, SDD, flash drive, and the magnetic tapes. All these devices are used as in secondary storage. Even these devices you can remove these storage from the computer and plug into the other computers for accessing the data. So the main functions of the memory unit are, first one is the storing of the data and storing of the results, and it work for execution of the programs, and because the programs are stored into the memory, so for program execution it helps for the execution. because all the instructions are kept into the storage memories. Next one is the control unit. So control unit is basically managing the devices that and components that are attached in a system. So it basically work as a manager or manage the computer devices and its functioning, uh, or and it is basically the central component of the computer system. So next, it interprets the signal and send it over to the output unit. When the results are generated, then the signal is sent to the output devices for representation of the data. So this is the architecture of the control unit. This is one is the control unit. It having different types of signals, like status and the condition of the code. This is driven by the clock pulse, and the instruction registers are there that are controlled by the control unit, and these are the signals that are sent to the CPU for controlling the execution of the instruction, that which program will be execute their instruction. So that is controlled by the this control unit. And this the next, the control signals are sent for the buses, for the external buses, for controlling the buses, that which device will be or which device will access these buses. And the further the control signals are generated for the uh, external buses, that they are used for the data transfer or they are used for the address transfer. So everything is controlled by the control unit. So the main function of the control unit is to coordinate between the memory unit and the IO devices and convert the instructions into the machine language, because computer is completely understands the 01 language only. So the decoding of the instructions and sending the instructions to the correct devices is controlled by the control unit. And next, the preparation of the data sequence that will be processed by the processor is also controlled by this control unit, and it maintain the flow of the data which is flowing between the buses and data buses and the address buses and between the devices is all controlled by the control unit. So the management or the controlling is work by the control unit. Next one is the arithmetic and logic unit, and that is called as the ALU. So all the mathematical equations and the logical operations are performed by the ALU, and the it is useful for data comparison, and the actions that are used for the decision making are done by the ALU. So ALU gets the data from the memory into the registers, as we have already discussed that there are different types of registers in a CPU that are directly accessed by the ALU, because ALU is not directly accessing the main memory. ALU is accessing the registered memory. So the instructions and the data which will be executing next are stored into the registers. So these registers are kept the memory address, data manipulations and the processings are kept by the registers. So everything is the calculations are performed by the ALU, and this is the circuit diagram of the ALU for the full adder. So there are this is the 4-bit full adder. So these full adder contains the logical circuit, and two inputs are given to the full adder, A and B, and this is the carry bit, that is If there is any previous carry that should be added into the A plus B, then it is supplied and the summation results are generated using these full adders, and the carry, further carry is generated here. Okay. So all the arithmetic operations which are done by the ALU are done by the logic gates. So mainly the functions of the ALU are to perform the calculations and the mathematical issues that should be executed by the computer, and it basically compare the data and enable the transfer the data between the primary and the secondary memory by decoding it, and it is used for the decision maker. So the basic, so everything that are important are fused on the motherboard. So the motherboard is contains the CPU. CPU. This is, as I have already discussed, that this is the CPU chip, contains the number of cores like single core, dual core, quad core, and they are raised in the power of 2 basically, and these are the RAM slots. Okay, and this one is the power connector. Okay, this one is the power connector, and this is the USB 3-pin header, and this is the BIOS that are used for to start the every device of the computer, and this is the SATA for data transfer, and next this one is the BIOS battery, and next these are the audio chips, PCI slots. These are where you can connect your pen drive and the projector connections. Okay, so these are the external ports. Okay, so if you have any query, you can comment me or mail me. Thank you.